Hi everyone, in this video we will be going over how to figure out probability from a pedigree. The first example we will be looking at today is an autosomal recessive trait. So looking at this trait, the question that we are going to answer is, what is the probability of offspring 4-8 and 4-10 being affected by this gene? The first thing we have to remember is that in order for an individual to be affected by this trait, they must be homozygous. Additionally, we're going to say this is a rare trait, so that way we know that no partners joining the family are carriers. So we're going to look at these two offspring here. So the first thing we can do is determine all the carriers of this trait. We know that since it's autosomal recessive, all affected people are homozygous recessive. This means that all their offspring must receive at least one recessive allele, and therefore they are carriers. So we can put in circles for all of their offspring. This helps us narrow down a lot of information. We know that 4-8 is a carrier. However, how would we figure out 4-10? This is where probability comes into play. So we know that 3-10 is for sure a carrier of this trait. Although we cannot tell for sure whether 3-11 is a homozygous dominant or a heterozygous individual, we can assume that they have a homozygous dominant genotype because we know that this trait is rare, and therefore no partners coming into the trait will be carrier. We need to figure out whether 4-10 is a carrier or simply homozygous dominant. So 3-10 has a 1/2 chance of passing on their recessive allele to their offspring, since they are heterozygous. This means that 4-10 has a 1/2 chance of being a carrier. And then if they have offspring, there is another 1/2 chance that they will pass on recessive allele to their offspring. Additionally, we know that 4-8 is a carrier, but they still have a 1/2 chance of passing on this same trait to their offspring. And now that we know the probability of each of them having this trait and also passing on this allele to their offspring, we can multiply it all together. So 1/2 cubed is 1/8. So the probability that offspring of 4-8 and 4-10 being affected by this trait is 1/8. Here's another example that we will go over in this video. This is an X-linked recessive trait. Since males only have one X chromosome, they are more likely to have X-linked recessive traits. So we know that if a male has this trait, then his mother must be at least a carrier. We also know that if a male has this trait, he must pass it on to his daughter, since one of her X chromosomes has to come from his X chromosome. So now what we're going to figure out is what is the probability that the daughter of 4-6 and 4-10 are affected by this trait. So we know that 4-10 has one X chromosome from the father, which has to be dominant for this trait. 3-10 has a 1/2 chance of giving off this recessive chromosome to her daughter. Similarly, if this daughter is a carrier, she will also have a 1/2 chance of passing on the recessive chromosome to her daughter. And we know that males only have one X chromosome, and therefore he has a 100% chance of passing on his affected X chromosome to his daughter. If we multiply all of this together, we get 1/2 times 1/2 times 1, which equals 1/4. And that is our answer for this question. So that was the answer for that question, but that's assuming that individuals 4-6 and 4-10 already have a daughter. But if the question was asked like this instead, where it says, what is the probability that individuals 4, 6, and 4, 10 have an affected daughter, you would also have to consider the probability of having a daughter, which we know is 1 half. And you can figure this out from a basic Punnett square. From this Punnett square, we can easily see that 2/4 or 1/2 of the offspring will be daughters. So since we already know that the probability is 1/4 of passing on this trait to an affected daughter, we need to figure out what's the probability of having a daughter as well and multiply that to the 1/4. So that's 1/4 times 1/2, which is equal to 1/8. So these questions are similar but not entirely the same because the first one's already assuming that they have a daughter, but in this question you have to think about the probability of also having a daughter on top of the possibility of passing the gene down to a daughter.